As you can see, I've already shown all my working out for this question. I'll just talk you through it. We're told that y is equal to e to the power minus x times sine root 3x. And we're asked to find the exact values of the constants r and alpha so that dy by dx is equal to this thing here. So we need to differentiate. And we need to differentiate this with the product rule because we've got the product of two functions. We've got the e to the minus x and the sine root 3x. So over here, I've used the product rule. I've said that my u is the e to the minus x and my v is the sine root 3x. I've differentiated each of those. So e to the minus x is going to differentiate to be minus e to the minus x. The sine is going to differentiate to be cos, and then I need to remember to multiply by the root 3 because of the chain rule. Now that I've differentiated each of those, I'm going to apply the product rule, which is u dash times v. So that's what I've got here. Plus v dash times u. So that's what I've got over here. Right. So I've done the differentiation and got this thing here. Now it's a case of being able to rewrite that like the question asked. So first thing I've done is I've factorised out the e to the minus x. So that's left me with the minus sine root 3x at the front and the root 3 cos root 3x at the back. Now, just because I don't like having this minus bit at the front, I've just swapped these around. So I've written the positive root 3 cos root 3x at the front and the negative sine root 3x at the back. Right. Next, it's about being able to rewrite this thing in the form of r cos root 3 plus alpha, because I've already got this e to the minus x here and there. So what I've done, I've taken the r cos root 3x plus alpha and I've expanded that out using the addition formula. So I've got r times cos 3x cos alpha minus in the middle because it's a plus here, r sine root 3x sine alpha. So this is me just expanding that out using the addition formula from the formula sheet. And then it's a case of me comparing. I'm comparing this result to what I had over here. So let's do that really carefully. So I can see I've got a cos root 3x here and I've got a cos root 3x here, which means that this r cos alpha is going to have to be equal to the root 3. So that's what I've written down here. And then we've got the sine root 3x here and a sine root 3x here, which is going to mean that the r sine alpha is just going to need to be 1 because there's no number at the front there. So there's a 1. So that's what I've written there. From there, I've divided both sides by r to get this and this. And then I've drawn a little right angle triangle to allow me to work out what r and alpha are going to be. So I've drawn my right angle triangle. I've put 1 over here on the opposite side because I can see that the opposite would need to be 1 because remember sine is the opposite over the hypotenuse. So that's why I've put 1 on the opposite side and r on the hypotenuse. I've put √3 on the adjacent side because I can see here that cos is the adjacent divided by the hypotenuse. So the adjacent would need to be √3. I've then done a little bit of Pythagoras to work out what r is and found that it's 2. And then I've said that tan theta is the opposite, so that's the 1, divided by the adjacent, which is the √3. And then when I do tan inverse of 1 over √3, I find that alpha is pi over 6. So if r is 2, and if alpha is pi over 6, then we know that this thing here is identical to this thing here, which means I can replace it like that. And then I've just multiplied that by the e to the minus x. So just expanded those brackets to make it so it looks exactly like the question asked for.